Please subscribe, like, and share. It really helps us out. And of course, if you have any questions, comment below and we will answer you as soon as we can. Hey everyone! Welcome back to our IGCSE Chemistry series. Today, we're diving into the world of atoms, elements, and compounds, the building blocks of everything in chemistry. By the end of this video, you'll know how to identify elements, form compounds, and explain how atoms bond together. Let's get started. Everything in the universe is made of atoms, tiny particles too small to see. An element is a pure substance made of just one type of atom. Examples? Hydrogen, oxygen, and carbon, all found on the periodic table. A compound is formed when two or more elements are chemically bonded together. For example, hydrogen and oxygen combine to make water, and sodium and chlorine form table salt. And then there are mixtures, things like air or seawater. They contain multiple substances that aren't chemically joined, so we can separate them physically, by filtration, distillation, or chromatography. So, element equals pure, compound equals bonded, mixture equals mixed but not joined. Simple. Now, let's zoom inside the atom. At the center is the nucleus, made of protons and neutrons. Around it is the electron cloud, where negatively charged electrons move. Each atom has a few key numbers. The atomic number is the number of protons. The mass number is the total of protons plus neutrons. Since atoms are neutral, the number of protons equals the number of electrons. Remember, protons define the element. If you change the number of protons, you get a different element altogether. Sometimes, atoms of the same element can have different numbers of neutrons. These are called isotopes. For example, hydrogen can exist as hydrogen 1 and hydrogen 2, same number of protons, but different masses. So, same element, different isotope. Atoms love being stable, they want full outer shells of electrons. To do that, they can lose or gain electrons to form ions. When a metal atom loses electrons, it becomes a positive ion, cation. When a nonmetal gains electrons, it becomes a negative ion, anion. Opposite charges attract, and that's what forms an ionic bond. For example, sodium loses one electron, chlorine gains one electron, together, they form sodium chloride, or table salt. Ionic compounds form giant lattices with strong electrostatic forces, that's why they have high melting points and conduct electricity when molten or dissolved in water. When nonmetals bond, they usually share electrons, forming covalent bonds. Each shared pair of electrons creates a bond between atoms. For example, H2, hydrogen gas, O2, oxygen, H2O, water molecule. These are simple covalent molecules, small, low melting and boiling points, usually poor conductors. But some nonmetals form giant covalent structures, where atoms are linked in a massive 3D network. Examples include diamond, graphite, and silicon dioxide. Diamond is extremely hard because every carbon atom bonds to 4 others. Graphite, on the other hand, has layers that can slide, and free electrons that conduct electricity. Metals bond differently again. In metallic bonding, positive metal ions are surrounded by a sea of delocalized electrons. These electrons can move freely, which is why metals conduct electricity and heat. The layers of ions can also slide over each other, making metals malleable and ductile. And that shiny metallic luster? That's the delocalized electrons reflecting light. So in summary, ionic, high melting points, conductors when molten, covalent, low melting, nonconductors, giant covalent, super high melting, mostly nonconductors, metals, shiny, strong, and excellent conductors. Practice writing electronic configurations, like 2,8,1 for sodium. Memorize common ions and their charges. Be able to draw dot and cross diagrams for ionic and covalent compounds. And always check whether something is a metal or non-metal before deciding which bonding type it forms. And that's everything you need to know about atoms, elements, and compounds for your IGCSE Chemistry exam. If this helped, hit that like button, subscribe for more quick science explainers, and check out the next video on stoichiometry, coming up next. Thank you for watching our video. Please like, subscribe and share. And comment below so we can clarify things for you.